All right, we're looking here at how to solve quadratic equations. But before we begin, we're going to look at what a quadratic function is compared to what a quadratic equation is. So first of all, quadratic functions, quadratic means they have to have a degree of 2. To be a function, it has to have 2 variables, and that means it can be graphed. So I have a couple of examples here. The first quadratic is y equals 2 bracket x minus 4, close the bracket, bracket x plus 5. That is quadratic because if I were to expand and simplify it to write it in its standard form, I would get an x squared, so it's degree 2. It has 2 variables. It has a y and it has x's, so 2 variables, which means I can plot it on the xy plane or the Cartesian plane. The second one is more like a context question where h could be height and t could be your time in seconds. So these are your typical balls have been thrown up in the air or a rocket has been launched off the roof of a building or some kind of question like that. But again, when you expand and simplify that, you get your degree 2. It has the 2 variables. It can be graphed. So that's a function. The key is the one variable depends on the other variable. A quadratic equation, on the other hand, it still has degree 2 to be quadratic, but there's only one variable this time. So if you look at the examples down at the bottom, you'll notice that I replaced the y with a 0 and I replaced the h with a 0, but the rest of it stayed the same. So now I only have one variable in there. If I'm solving this equation, it's like finding the x-intercepts of the related quadratic function. So if you look at that first example that I have down under here, all I've done is replaced the y value with a 0, and then that would be finding the x-intercepts of the related function above. Similarly, the second one, I replaced the h up from that second example on the first part with a 0, so I would be finding the time, t for time, when the height is 0. I'm finding the t-intercepts there. The solution to these equations will be the value or values, because sometimes there's more than one, of the variable that makes the equation true. In other words, what value of x could I sub into here to make this work out to be equal to 0? What value of t could I sub into the second example that would work so that the outcome would be 0? Now, we also know that since it's like finding the x-intercepts, if you think of a parabola could cross the x-axis at 2 spots, so it could have 2 solutions. We could have a parabola sitting right on the let's try that again, I'm having trouble, there we go, right on the x-axis, and that has just one solution. Or you could have a parabola that never dips low enough, or if it opens the other way, never goes high enough to have any solution, any x-intercepts, which means the related quadratic equation would have no solutions. So quadratic equations can have one solution, 2 solutions, or no solutions, and that's why I'm using value or values of the variable that would make the equation true. These solutions are also known as the roots of the equation. So if you see an example that says solve for the roots, it's meaning just get what the x-intercepts are, or what is the solution, what value of the variable will make the equation true. Find the roots means solve the equation. All right, we have 3 main forms of our quadratics, and the first one we looked at was this vertex form. And when we have the vertex form, that's the one that is the y equals a bracket x minus h all squared plus k. To be able to solve that quadratic equation that's in that form, I'm going to actually eliminate the y there. I'm going to put a 0 because we only have one variable. Whoops, a 0 goes here. To be able to solve this, you actually isolate for the variable by doing SAMDEB. So I'm going to write that in here. Use SAMDEB, bedmiss backwards. So undo adding and subtracting first, undo multiplying and dividing next, undo the exponent, and then undo what's inside the bracket with it. So use SAMDEB to isolate for the variable. So we have an example here. Just finish writing that in here though. For the variable. So we're isolating for the variable. So I have this example. I'm using the one from up above, and I have my variable right here, but I've got something in brackets with it. I've got an exponent. I've got a multiply, and I have a plus. So we're going to undo the plus first by subtracting 80 from both sides. So we're doing Sam, Deb, undoing, adding, and subtracting first. So we're going to end up with negative 80 being equal to negative 5 bracket t minus 2 all squared. Okay, so I've undone the adding by subtracting. Now I'm going to undo the multiplying. So I'm multiplying by negative 5. I'm going to undo that by dividing both sides by negative 5. And negative 80 divided by negative 5 is 16. So 16 is going to equal my t minus 2 all squared. Next, I'm going to undo the exponent. The opposite of an exponent 2 is a square root. And when I square root, there's always two answers. There's a positive answer and the negative answer. So if I square root 16, I'm going to get 4. So I have positive 4 or negative 4 being equal to t take away 2, because the square root now has undone that exponent of 2 there. All right, and then to get t by itself, I'm undoing what was inside the bracket with it. It was a minus 2, so we're going to add 2 to both sides, plus 2 to undo that, and we need to plus 2 to this. So that gives me two possible values for t. I could have positive 4 plus 2, so t will equal positive 4 plus 2, or my t would equal the negative 4 plus 2. And when we calculate those, I get t equals 6 or t equals negative 2. Okay, so if I wanted to actually think about what that parabola would look like, I could do a little sketch here. My t-axis is my independent variable, and my height depends on the time. I have two x-intercepts, one at negative 2 and one at positive 6. So, and my parabola is opening down. Ooh, that was really bad. It turned it into a straight line in the middle of that. There we go. So this one is my negative 2 value. That's my one solution. My positive 6 would be over here. So it's related to the function, the original function. My vertex, if you think of vertex form, the vertex was at positive 2, positive 80. Just recalling what you know from vertex form. It's always good to review as we go. All right, so that hopefully should make sense there. We're going to move on to the next part, how to solve the equation from its factored form. Okay, and if you have the factored form, you want to make sure that you have 0 on one side of the equal sign. So all of these I did put 0, I did put 0 on one side of the equal sign, so you don't have to worry about that. If you didn't, then you would have to actually expand it and simplify it. But as long as you have 0 on one side, you're good to go. Now, we already talked about this in terms of if this was a y, we know that solving the related quadratic equation would be like finding the x-intercepts. So for the x-intercepts, we're really replacing the y with the 0, like we've done here. And then we had talked about how to get those x-intercepts. We said whatever number's in the bracket with the x, just switch the sign. So we should have x equals 4 and an x equals negative 5. Now the question is, why do we switch the signs? Well, here's what's happening. We're setting each factor equal to 0, and we're solving, that's not supposed to say sol, it's supposed to say solve the mini equation. So really what we have here is either x minus 4 equaling 0, which gives us x equaling 4 when I add 4 to both sides to get x by itself, or we have x plus 5 has to be equal to the 0, which means x equals negative 5. Now let me back that up even further. Well, why is that true? Well, let's think about this here. We have to have a value of x that's going to make our equation true. So 2 times this thing, x take away 4, times this thing, x plus 5, has to equal 0. And the only way you get an answer of 0 when you're multiplying two or more things together is if one of those two things is actually 0 itself, meaning either x plus 4 is equal to 0, x minus 4 is equal to 0, which then means that x would have to equal 4, because if I put 4 right here to replace the x, I would have a 2 times 4 take away 4, which is 0, times 9. That would result in 0 and make the equation true. Likewise, my x plus 5 could equal 0, meaning that x has to equal negative 5. So the bracket on the end here would be negative 5 plus 5, which would equal 0, times negative 5 take away 4 would be negative 9 times the 2, which will ultimately equal 0 overall. Okay, so the whole thing with the reason the zeros were what's in the brackets attached to the x but with the opposite sign is based on that premise. And I said that only works if the coefficient of x was 1. When the coefficient of x is not 1, it's a little bit more complicated, but the process is the same. We're going to set each factor equal to 0. So we're going to get 3x take away 2 has to equal 0. And then I'm going to solve that little mini equation. I'm going to add 2 to both sides to get 3x equals 2. And then divide both sides by 3, and we get x equals 2/3. So let me just write in what I did here. I added 2 to both sides, and then I divided both sides by 3. So x equals 2/3 would be one solution. The other one comes from 5x plus 7 equaling 0. I'm going to subtract 7 from both sides. And I'm running underneath the other equation, unfortunately. So 5x equals negative 7. Divide both sides by 5. X equals negative 7/5. Negative 7/5. All right, the last one is one that people find tricky. And the reason is they see what the one factor is. The one factor is 2x minus 1, and we know it has to equal 0. Add 1 to both sides. Divide both sides by 2. X equals 1/2. The other factor is just this thing right here, just the x. And it's simple enough. It's just x equals 0. Done. Okay, so that's how you can solve from factored form. I have another video that's going to follow this up, and what if you have standard form? And we're going to look at one option in this lesson, and then we'll continue on the next lesson with the other options.